Assistant Professor, Computer Science and Engineering of Dr. MGR Educational and Research Institute. It gives me the immense pleasure to welcome you all today for the 6 days virtual faculty development program on transformative approach in computing paradigms, machine intelligence, and quantum computing, organized jointly by the Department of Computer Science and Engineering in association with Center of Excellency CMT and Department of Cybersecurity of Dr. MGR Educational and Research Institute. So today we are privileged to have with us Dr. N. Chaitanya Kumar, Professor, Department of CSE, KL University, Hyderabad. To introduce Sir now, I invite Dr. Dinesh Kumar, HOD, Department of Cybersecurity, to give the brief introduction about the today's speaker. Sir.
Yes, ma'am. Thank you. Good afternoon to all. Dr. N. Chaitanya Kumar is a professor of computer science and engineering with over 24 years of academic experience in teaching, mentoring, curriculum development, academic administration, and research supervision. He holds a PhD in computer science from the University of Hyderabad with a research focused on decentralization, proactive secret sharing, cryptography, distributed system, and secure communication for source constrained environment. His academic and research interests include artificial intelligence, machine learning, data structure and algorithms, cybersecurity, cryptography, blockchain, distributed computing, Internet of Things, and technology-enabled education. He is guided his students in academic project, research writing, technical problem solving, and practical implementation based learning. He has also contributed to publication, patents, books, and conference activities in the areas of computing and emerging technology. Dr. Kumar has extensive experience in outcome-based education, online and blended teaching, project-based learning, academic coordination, and student mentoring. He is passionate about simplifying complex technical concepts, connecting theory with real-world application, and helping learners build strong analytical programming, research, and professional skills. On behalf of Dr. MJ Education Institute and Department of Computer Science and Engineering, we welcome you, sir. Thank you.
Good afternoon, everyone. I thank the organizers for inviting me to this FDP. Today's session is titled From Chatbots to AI Agents. Practical Machine Intelligence for Education, Industry, and Daily Life. The purpose of this session is to understand machine intelligence not only as a theory, but as a practical technology that is already changing education, industry, research, administration, and daily activities. We will begin with simple AI concepts, then move to chatbots, generative AI, multimodal AI, and finally AI agents. Along the way, we will discuss real applications and also see a few live demonstrations. By the end of the session, the goal is to understand how AI tools can be used effectively, responsibly, and productively in our academic and professional work. Now let us look at the roadmap for today's session. This session is designed as a gradual journey. We will not directly jump into advanced AI agents. First, we will build a simple understanding of machine intelligence and why it has become so important now. In the first part, we will discuss the basic difference between artificial intelligence, machine learning, deep learning, and generative AI. These terms are often used together, but each one has a specific meaning. We will also see how AI systems evolved from simple rule-based chatbots to modern large language model-based chatbots. After that, we will move to the main idea of this lecture, AI agents. A chatbot mostly answers questions, but an AI agent can work toward a goal. It can plan, use tools, analyze documents, generate outputs, and assist in completing real tasks. In the second part, we will discuss practical AI capabilities like prompt engineering, document understanding, image understanding, multimodal AI, and retrieval augmented generation. These are very useful in teaching, learning, research, and administration. In the third part, we will focus on real applications. We will discuss how intelligence can support education, academic administration, industry workflows, research activities, and daily life tasks. Finally, we will look at live demonstrations and responsible use. We will see how AI can act as a teaching assistant, department assistant, and personal learning assistant. At the same time, we will also discuss important concerns such as hallucination, privacy, bias, overdependence, and ethical usage. The overall goal is simple. By the end of this session, we should be able to understand not only what AI tools can do, but also how to use them effectively and responsibly in real academic and professional situations. Before going deeper into technical concepts, let us first understand why mission intelligence matters so much now. Mission intelligence is no longer something that belongs only to research labs or large technology companies. It has already entered our daily life. Many times, we use it without even noticing it. For example, when we use face lock on mobile phone, when Google Maps suggests the fastest route, when YouTube channels recommends the next video, when online shopping platforms recommends products, or when Gmail filters spam messages. Mission intelligence is working in the background. In education also, AI is becoming very useful. It can support teachers in preparing lesson plans, generating quiz questions, summarizing documents, creating rubrics, and explaining difficult concepts to students at different levels. For students, it can act as a learning companion, doubt clarification assistant, and practice question generator. In industry, AI is already used in customer support, coding assistance, business analytics, report generation, HR support, fraud detection, and workflow automation. Many routine and repetitive tasks are now being assisted by intelligent systems. The most important shift is this. Earlier, AI was mostly used for prediction and recommendation. Then chatbots started answering our questions. Now AI is moving toward task completion. This is where AI agents become important. So the reason we are discussing this topic today is simple. Machine intelligence is not only changing technology, it is changing the way we learn, teach, work, communicate, and make decisions. Now, let us clearly understand a few terms that are commonly used in discussions about machine intelligence. The first and broadest term is artificial intelligence. AI simply means making machines perform tasks that normally require human intelligence. For example, recognizing speech, understanding language, identifying faces, recommending videos, or answering questions. Within AI, we have machine learning. In machine learning, we do not manually write rules for every situation. Instead, the system learns patterns from data. For example, if we give many examples of spam and non-spam emails, the system learns how to classify future emails. Then we have deep learning, which is more advanced form of machine learning. It uses artificial neural networks with many layers. Deep learning is very useful for complex tasks like image recognition, speech processing, language translation, and self-driving systems. The next important development is generative AI. Unlike traditional AI systems that mainly classify or predict, generative AI can create new content. It can write text, generate images, prepare code, summarize documents, create lesson plans, and even support audio and video based tasks. Now we come to the most important term for today's lecture, AI agents. An AI agent is not just a chatbot. A chatbot mainly responds to what we ask, but an AI agent can work toward a goal. It can plan steps, use tools, read documents, generate outputs, and assist in completing a larger task. For example, if we ask a chatbot, what is meeting agenda? It will explain the meaning. But if we ask an AI agent to help conduct a meeting, it may prepare the agenda, draft the email invitation, create a checklist, summarize previous points, and prepare the minutes format. So the key distinction is chatbots answer, but agents assist in completing tasks. This is the central idea we will explore throughout today's session. Now, let us see how machine intelligence has evolved over time. In the beginning, many intelligence systems were rule-based systems. These systems work using fixed rules written by humans. For example, if a condition is true, then the system performs a particular action. These systems were useful, but they were limited because they could not easily handle new or unexpected situations. Then came machine learning. Instead of writing rules manually for every case, we started giving data to the system. The machine learned patterns from the data. A simple example is email spam detection. The system studies many spam and non-spam emails and then learns how to identify spam in the future. After that, deep learning became popular. Deep learning uses neural networks with multiple layers. It is especially powerful in areas like image recognition, speech recognition, natural language processing, and face recognition. For example, when our mobile phone recognizes our face, deep learning may be working behind that system. The next major shift was generative AI. Traditional AI was mostly used for classification prediction, or recommendation, but generative AI can create new content. It can write emails, summarize documents, generate images, write code, prepare lesson plans, and explain concepts. Tools like ChatGPT, Gemini, Claude, and Copilot belong to this new wave of AI usage. Now we are moving toward AI agents. This is the next important stage. An AI agent is not limited to answering a question. It can understand a goal, break it into steps, use tools, work with documents, generate outputs, and help complete a task. So the journey is very clear. First, missions followed rules, then they learned from data, then they started generating content, and now they are beginning to assist in completing real tasks. This evaluation is the foundation for today's topic, from chatbots to AI agents. Now we come to one of the most important ideas of today's lecture, the difference between a chatbot and an AI agent. A chatbot is mainly designed for conversation. We ask a question and it gives an answer. For example, if we ask, explain machine learning in simple words, it will give us an explanation. If I ask it to write an email, it can prepare a draft. If I ask it to summarize a paragraph, it can do that also. So a chatbot is very useful for answering questions, explaining concepts, summarizing content, writing drafts, and generating text. But generally, the interaction is one step at a time. The user has to guide it continuously. An AI agent, on the other hand, is more goal-oriented. It does not just answer one question, it tries to understand the larger goal and then break it into smaller steps. For example, suppose we say, help me conduct an academic event. A chatbot may explain what an academic event is or give a general plan. But an AI agent can help prepare the agenda, invitation email, registration form fields, feedback questions, certificate text, and post-event report format. That means an agent is closer to a task assistant. It may use tools, documents, memory, workflows, or external systems to complete a larger activity. So the simple difference is this. A chatbot supports conversation. An AI agent supports task completion. This is why the today's topic session is from chatbots to AI agents. We are moving from simply asking AI questions to using AI for real academic, professional, and daily life tasks. Now, let us understand how an AI agent works internally. An AI agent starts with a goal. The user does not simply ask for one small answer. Instead, the user gives a task to be completed. For example, help me prepare for exam, or prepare a complete report from these documents. After receiving the goal, the agent performs reasoning. It tries to decide what steps are needed. It may break the task into smaller parts. For example, to prepare a lecture, it may identify that we need a title, or whatever the subject concepts that are required. The next part is tools. A modern AI agent may use tools such as document reading, web search, coding tools, calendar tools, file generation tools, or email drafting tools, depending on the task that is given. This is what makes it more powerful than a normal chatbot. Then the agent performs an action. It may draft content, summarize a document, analyze data, or it may prepare a checklist, generate a code, or create a report. Finally, there is a feedback and improvement. The first output may not always be perfect. The agent can revise the answer based on human feedback or based on checking the result. So an AI agent is not just a question answer system. It is a goal-oriented assistant that can plan, use tools, produce outputs, and improve them. A simple way to remember this is goal, reasoning, tools, action, feedback. That is why AI agents are becoming important in education, industry, and daily life. They help with tasks that involve multiple connected steps. Now let us understand AI agent workflow through a very common academic scenario. Student mentoring and counseling follow-up. In every academic department, mentors regularly support students who have low attendance, poor academic performance, irregular class participation, or lack of motivation. This is not a one-step activity. It usually needs counseling, parent communication, action planning, and continuous follow-up. So instead of asking AI one small question like write a message to student, we can give a larger goal. Like help me prepare a mentoring and follow-up plan for academically weak students. Now the AI can break this goal into smaller steps. It can help identify possible student issues, prepare counseling questions, draft a parent communication message, create an improvement plan format, and prepare a weekly follow-up checklist. The AI can also generate useful documents such as mentoring note format, student counseling template, parent message draft, improved plan table, and weekly follow-up tracker. This is what we mean by agentic overflow. The AI is not just answering one question, it is supporting a complete academic process. However, the human role is very important here. Student mentoring requires empathy, personal understanding, and responsibility. AI can help with documentation and structure, but the mentor must speak to the students personally, understand the real situation, guide properly, and record the follow-up. So the key message is AI assists in organizing the workflow, but the mentor remains responsible for the actual guidance and decision making. Now, let us look at the practical applications of machine intelligence in education. In teaching, AI can support faculty members in several routine but time-consuming activities. For example, it can help prepare lesson plans, lecture notes, examples and analogies, slide outlines, assignments and rubrics, etc. This does not mean the teacher's role is reduced. Actually, the teacher's role becomes more focused on validation, evaluation, mentoring, and delivery. For student learning, AI can act as a personalized tutor. A student can ask the same concept at different levels. For example, explain machine learning to a first-year engineering student, or explain the same concept with a real-life example. AI can also generate practice questions, simplify difficult concepts, and support language translation or communication improvement. In assessment and administration, AI can help generate MCQs, map questions to Bloom's taxonomy, prepare feedback forms, summarize feedback, draft circulars, and prepare reports. These are very useful in academic environments where faculty handle teaching, evaluation, mentoring, documentation, and administrative work together. A very practical example is this. A faculty member can upload a syllabus and ask AI to prepare unit-wise outcomes, lecture plans, MCQs, assignments, and slow learner support material. The AI can quickly generate a first draft. The teacher can then verify, correct, and improve it. The key point is very important. AI does not replace the teacher. It increases preparation speed, personalization, and academic productivity. But the final academic responsibility always remains with the human teacher. Now, let us move from education to industry. In industry, machine intelligence is mainly used to improve speed, accuracy, automation, and decision making. Companies are not using AI only because it is a new technology. They are using it because it can reduce repetitive work, improve productivity, and help people make better decisions. I can see someone raising a hand. Yes, I can see someone raising a hand, but if at all you have any questions, better we can discuss at the end. Let us continue. In business operations, AI is used in customer support, so chatbot, this we already discussed, email automation, meeting summaries, report generation, and HR screening support. In technical workflows, AI is now widely used by software developers. Coding assistants can explain code, suggest improvements, detect bugs, generate test cases, and prepare documentation. This does not mean that programmers are no longer needed. Rather, programmer can work faster when AI supports routine coding and debugging tasks. In data-driven decision making, AI is used for sales prediction, fraud detection, demand forecasting, risk analysis, and predictive maintenance. For example, in manufacturing, AI can study sensor readings and predict whether a machine may fail soon. This helps the company perform maintenance before a breakdown occurs. One simple industry example is customer complaint analysis. Suppose a company receives thousands of complaints. AI can summarize them, classify them into categories, identify repeated issues, and suggest common response templates. This saves time and gives management better insight. So the key message is, in industry, AI is valuable when it is ready to work and support faster, better informed decisions. Now let us look at how machine intelligence is entering daily life. Today, AI is not limited to research, education, or industry. It is becoming a personal assistant for ordinary daily activities. For example, we can use AI to draft emails, improve resumes, plan tasks. We can prepare a checklist and organize travel plans. AI is also useful for learning and creativity. A person can use AI to learn a new skill, translate text, generate content ideas, prepare video scripts, create posters, or understand a difficult topic in simple language. In daily decision making also, AI can support us. It can help compare products, prepare a budget, suggest routes, explain health related information in simple language, or provide safety related suggestions. However, we must be careful. AI can help us understand, but important decisions must still be verified using reliable sources. For example, if someone wants to plan a one-day trip, AI can suggest places to visit, estimate the budget, prepare a checklist, draft messages, and organize the schedule. This is again agent-like behavior because the AI is not just answering one question, it is supporting the complete activity. The key point is AI can assist daily decisions and improve productivity, but we should not blindly accept every output. We must verify facts, especially in areas such as health, finance, law, travel, and safety. Now, we will move to the first live demonstration, prompt engineering. So I called it live demonstration. The reason is I want you to give the same prompts into different AI tools so that you know how the AI's agents are behaving. Prompt engineering simply means asking AI in a better and clearer way. Many people say that AI does not give proper answers, but often the problem is not with the tool alone. The problem is also with the way we ask the question. Let us take a simple example. If we give a weak prompt like write about AI in education, the AI will still generate an answer, but the answer may be general. It may not know the audience, the expected length, the purpose, or the format. Now, let us improve the prompt. We can say, act as an academic speaker, explain AI in education for first year engineering students, include 3 examples, 1 benefit, 1 risk, and 1 simple conclusion. Immediately, the response becomes better because we gave more direction. We specified the role, the task, the audience, the required content, and the structure. This is the most important rule. AI gives better output when we give better instructions. A good prompt generally includes 6 things: role, task, audience, context, output format, and constraints. For example, instead of asking prepare a circular, we can ask act as a department coordinator, prepare a formal circular for BTech students about some guest lecture. Include date, time, venue, attendance instruction, all things you can include. That is why prompt engineering is one of the basic skills needed for using AI effectively. Now we will use this prompt for the most effective result. The prompt is not just asking write about AI in education. It is more structured. We are telling the AI to act as academic speaker. We are also specifying the audience as first year engineering students. We are asking for simple language, 3 real examples, 1 risk, and clear conclusion. So the prompt includes everything. So this is important because AI tools do not automatically know our exact requirement. They need direction. When we give more useful context, the response becomes more useful. From the given response, we should observe 4 things. First, the response suitable for the audience. Since the audience is first year students, the explanation should not be too technical. Second, are the examples practical? The output should include examples such as AI tutors, quiz generation, personalized learning, or document summarization. Third, is the structure clear? A good AI response should not be a long, unorganized paragraph. It should have a clear beginning, middle, and conclusion. Fourth, is the tone suitable? Since we asked it to act as an academic speaker, the tone should sound appropriate for a classroom or FDP session. After that, we will give a follow-up prompt. Now, convert this explanation into 5 slide points with speaker notes. This shows another important advantage of AI. We can use the output as input for the next task. This is how we slowly move from chatbot usage towards agent-like workflow. The key learning from this demo is prompting is not just asking, it is giving AI the role, purpose, audience, and expected format. Now, let us move to another important development in machine intelligence, multimodal AI. Earlier, most AI interaction was text-based. We typed a question and the system gave a text answer. That was useful, but it was limited. In real life, our information is not only in text. We work with images, PDFs, handwritten notes, posters, screenshots, tables, audio, video, sometimes even coding also. Modern AI systems are becoming multimodal. That means they can understand more than one type of input. For example, we can upload an image and ask AI to describe it. We can upload a circular and ask it to extract action points. We can upload a syllabus and ask it to prepare lesson plans. We can upload a table and ask it to summarize trends. This is very useful in academic work. Suppose we have a poster, a question paper, or a student handbook, or a syllabus. Instead of manually reading everything, AI can help us summarize, extract important points, generate questions, or suggest improvements. For example, a faculty member can upload a question paper and ask AI to identify the topics covered, or Bloom's taxonomy levels, or difficulty distributions, or any areas that are missing. Similarly, a student can upload a diagram and ask for explanation. An office can upload a circular and ask for deadlines and responsibilities mentioned in that circular. So, multimodal AI is powerful because it reduces the gap between real world material and mission understanding. So this will lead us to our next demo where we can use AI to understand a document or image and extract useful information from it. In real academic work, we handle many types of documents. We receive circulars, posters, syllabi, question papers, reports, brochures, and meeting documents. Usually, we have to read them manually, extract the important points, identify action items, and prepare messages or reports. With multimodal AI, we can upload such material and ask AI to understand it. For this demo, upload an event poster, circular, syllabus, or question paper. Then ask AI. Analyze this document or image, extract the key information, summarize it in 5 points, identify action items, and suggest improvements. Now, the AI should be able to identify important information such as title, date, time, department, program name, speaker details, schedule, or any other key instructions that are mentioned. In an academic setting, this is very useful. A poster can be converted into an announcement. A syllabus can be converted into a lesson plan. A circular can be converted into an action checklist. Similarly, a question paper can be analyzed for topics and difficulty level. For example, if we upload the poster of this FDP, AI can extract the title, organizing departments, dates, mode, resource persons, and session details. It can also suggest how to make a short announcement for students or faculty. The learning from this demo is simple. Multimodal AI can convert raw documents and images into structured, useful outputs. But again, we should verify the output. AI can sometimes miss details or misread text, especially if the image quality is low. So, human checking is necessary before using the final result. Now, let us discuss an important concept called retrieval augmented generation, commonly called as RAG. When we ask a normal AI system a question, it usually answers based on its trained knowledge and the current conversation. This is useful for general topics, but in academic or institutional work, we often need answers based on specific trusted documents. For example, suppose a student asks about attendance rules or examination regulations, project guidelines, or course outcomes. A general AI system may give a broad answer, but it may not know the exact rules of our institution. It may also generate an incorrect or unsupported answer. This is where RAG becomes useful. In RAG, we provide trusted documents such as syllabus files, academic regulations, student handbooks, policy documents, reports, or research papers, like that. When a user asks a question, the system first retrieves the relevant portion from those documents. Then it generates an answer based on the retrieved content. So the flow is simple. Documents, retrieve relevant content, generate grounded answer. This is very useful in education. We can build a student handbook assistant, a syllabus question answering system, a research paper summarizer, or an academic policy assistant. For example, if a student asks, what is the minimum attendance requirement? The AI should not guess. It should retrieve the exact rule from the approved academic document and answer based on that. The key point is that RAG makes AI more reliable for institutional use because the answers are grounded in approved documents. However, even with RAG, human verification is needed for critical decisions. AI can assist, but official academic interpretation must still come from authorized persons. Now we will move to the third demonstration, AI as a department assistant. This demo is based on a very common academic task, conducting a monthly academic review meeting. In a department, this does not involve only one document. Usually, we need a meeting agenda, invitation message, attendance checklist, minutes of meeting format, action taken report format, and a follow-up email. So here we give the AI a larger goal. Act as a department AI assistant. Prepare a complete workflow for a monthly academic review meeting. Include meeting agenda, formal invitation message, attendance checklist, minutes of meeting format, action taken report format, and follow-up email draft. This is different from asking one small question. The AI has to understand the complete workflow and generate multiple connected outputs. This demonstrates agent-like behavior. The system understands the meeting goal, breaks the work into separate documents, prepares useful drafts, and allows us to refine each output further. For example, after the first output, we can ask, make the invitation message more formal, or convert the minutes of the meeting into a table format, or prepare the action taken report in action owner deadline format. So this is how AI becomes useful in academic administration. It reduces repetitive drafting work and helps us focus more on review, decision making, and follow-up. But the final responsibility remains with the department. AI can prepare drafts, but humans must verify, correct, approve, and communicate officially. Now we will see the fourth demonstration, AI as a student learning assistant. This is one of the most useful applications of machine intelligence in education. Many students hesitate to ask doubts repeatedly in the classroom. Some students may need a simpler explanation, while others may need more examples or practice questions. AI can help by explaining the same concept in different ways. So for this demo, we will ask, explain machine learning to a first-year engineering student using a simple example from YouTube recommendations. Then give 5 quiz questions with answers. This prompt is useful because it gives the AI a clear audience and familiar example. Most students understand YouTube recommendations. So the concept of machine learning becomes easier to understand. After that, we will give a follow-up prompt. Now explain the same concept to a school student in simpler language and give one real-life analogy. So this shows how AI can adjust the level of explanation based on the learner. The same concept can be explained to a school student, first year student, advanced students, or even a non-technical audience. This demo demonstrates personalized explanation, level-based teaching, example-based learning, and instant quiz generation. However, students should not blindly copy AI answers. They should use AI to understand, practice, and improve their learning. The final goal is not to but to think better with AI support. The main learning from this demo is AI can support students as a tutor, but must still verify, practice, and understand independently. Now we must discuss a very important part of machine intelligence, responsible AI usage. So far, we have seen how AI can help in education, industry, or daily life, or whatever the examples that demos that we discussed in document understanding, prompt engineering, and agent style workflows. But we should also understand what can go wrong. The first risk is incorrect output. AI sometimes gives answers that look very confident but are actually wrong. This is often called hallucination. It may generate wrong facts, fake citations, outdated information, or incorrect interpretation of a document. The second risk is ethical misuse. AI can produce biased responses. It can be misused for plagiarism, fake assignments, deep fakes, fake certificates, misleading content, or academic dishonesty. So AI literacy must include ethical awareness also. The third major risk is privacy. We should be very careful before uploading confidential documents. Student records, marks, institutional files, personal data, financial details, and unpublished research data should not be casually uploaded to public AI tools. For example, if we ask AI about an institutional rule without uploading the correct document, it may confidently produce a wrong answer. Similarly, it may generate a fake citation that looks real but does not exist. That is why every AI output must be verified before use. The simple rule is this: use AI as an assistant, not as the final authority. Human judgment, verification, and responsibility are compulsory, especially in academic, administrative, legal, medical, financial, and official contexts. After discussing what can go wrong, let us now look at a simple checklist for responsible AI usage. Before using AI, we should first define the task clearly. If the instruction is vague, the output will also be vague. We should also avoid uploading confidential information such as student records, marks, internal documents, or personal data, any unpublished research materials, or any content that is not officially approved. We should give correct context to the AI. For example, if we want a message for students, we should mention that it is for students. If we want a formal circular, we should mention the tone and format. If the answer must be based on official rules, we should provide the trusted document instead of asking the AI to guess. While using AI, it is better to ask step by step. We can ask for examples, limitations, and alternate versions. We can also refine the output using follow-up prompts. This is important because the first AI response may not always be the best response. After getting the output, we must verify it. We should check facts, references, citations, dates, names, numbers, and any policy related instructions. We should also remove generic content and add our own human judgment. For academic use, students and faculty should remember that AI should support learning, not replace learning. Students should not blindly copy AI answers. Faculty should use AI to speed up preparation, but the academic quality and final responsibility should remain with the human user. The golden rule is simple. AI can draft, suggest, and accelerate. Humans must verify, decide, and take responsibility. This balanced approach helps us use AI effectively without ignoring safety, ethics, and accountability. Now let us discuss the skills needed for the AI agent era. As AI tools become more powerful, The question is not only whether people know AI theory, the more important question is whether they can use AI meaningfully to solve real problems. The first set of skills is technical. Everyone may not need to become an AI researcher, but everyone should know how to use AI tools effectively. Basic prompt engineering, data literacy, coding logic, and automation thinking will become very useful. Even non-programmers should understand how to ask AI clearly and how to convert work into structured steps. The second set of skills is thinking skills. AI can generate answers, but humans must frame the problem properly. If the problem itself is not clearly defined, AI cannot give a meaningful solution. So, problem framing, critical thinking, fact verification, workflow design, and decision making are very important. The third set is human skills. Communication, creativity, ethics, collaboration, and responsibility will become even more valuable. AI can assist in drafting and generating, but it cannot replace human accountability. This is especially important for students. The future is not about competing with AI in routine tasks. The future is about learning how to use AI to solve meaningful problems. For example, instead of simply asking AI to write an assignment, a student should learn how to ask AI to explain a concept, generate practice questions, compare solutions, and improve understanding. Similarly, for faculty, AI should not be used only for quick content generation. It can be used to improve teaching quality, personalize student support, analyze feedback, and reduce repetitive documentation work. So, the key message is do not compete with AI in routine tasks. Learn to use AI to solve meaningful problems. Now, let us summarize the complete session. We started by understanding why mission intelligence matters today. We discussed that AI is no longer limited to laboratories or research papers. It is already present in our daily life, education, administration, and industry. Then we clarified the basic terms: artificial intelligence, machine learning, deep learning, generative AI, chatbots, multimodal AI, and AI agents. We also discussed the evolution of machine intelligence. Earlier systems were rule-based, then machines started learning from data. Later, deep learning enabled complex pattern recognition. After that, generative AI started creating text, images, code, and other content. Now, AI agents are emerging as goal-oriented assistants. During the session, we also focused on practical demonstrations. We saw how prompt engineering improves the quality of AI output. We discussed how AI can understand documents and images. We explored how AI can act as a department assistant and how it can support student learning. We also discussed real applications in education, industry, research, administration, and daily life. In education, AI can support teaching, learning, assessment, and administration. In industry, it can support automation, coding, data analysis, and decision making. In daily life, it can support communication, planning, learning, and personal productivity. Most importantly, we also discussed responsible AI. AI output should not be accepted blindly. We must verify facts, check sources, protect privacy, avoid misuse, and maintain human responsibility. The main takeaway is this: chatbots are useful for conversation. AI agents are useful for goal-oriented task completion. And the final thought is, the best users of AI will be those who can ask clearly, verify carefully, and apply responsibly. So with this, I would like to conclude my session. Today we discussed the journey from chatbots to AI agents. We started with the basic understanding of machine intelligence and then moved toward generative AI, multimodal AI, RAG, and AI agents. The main message of this session is that AI is no longer just a question answering tool. It is becoming a practical assistance for learning, teaching, research, academic administration, industry workflows, and daily life tasks. At the same time, we must use AI responsibly. AI can draft, suggest, summarize, and accelerate work, but human verification is essential. We must check facts, protect privacy, avoid misuse, and take responsibility for the final decision. So the real advantage will not go only to those who know AI tools. It will go to those who can frame problems clearly, ask good questions, verify carefully, and apply AI meaningfully. Thank you once again to the organizers for giving me this opportunity, and thank you all the participants for your patient listening. So now I will be happy to take questions, comments, or discussion points.
Sir, am I audible?
Yes.
Yes. Participants, any queries we can ask.
Sir, one question is there.
Okay.
Suggest some of the free agent AI tool, please.
I didn't get the question, ma'am. Can you please repeat?
Suggest some of the free agent AI tool, please. Free agent AI tool is asking, sir.
Okay, you want free agent AI tool. Okay. No, agent AI usually we are creating, ma'am. Let us say if I am using ChatGPT. If I am using ChatGPT prompt for the very first time, so it is acting as a chatbot. If I keep on asking in the same prompt again and again, giving my requirements or specifying the roles, audience, and everything, then the prompt becomes the agent. You don't have to create a separate agent. The prompt itself becomes the agent. So next time, whenever you give prompt in the same window, then your actual ChatGPT acts as an agent. So that is how you create different prompts for different workflows. So let us say if I want to manage my academic work, so everything I put in one prompt. So later that prompts itself becomes a next time whenever I am dealing something about my academic work, I don't have to tell the chat GPT about who am I, where I am working, or what is my basic requirement, because ChatGPT knows everything from the previous prompts. So that is how we create the agents.
Sir, next question, sir.
Okay, ma'am.
How we can design agent AI?
Madam, how we can design?
Design agent AI.
Agent AI.
Agentic AI.
Agentic AI, ma'am. That is what I explained just now. Agentic AI is the difference that we discussed is agentic AI is acting. So let us say from the session, whatever that we discussed, if I asked my AI agent to plan for this FDP, then the agentic AI will do everything. So starting from preparing the circular, attendance list, and then selecting the topics, and everything will be done by that agent itself. So now, just as I said, that agent you are creating by repetitively giving the prompts. You should not change the AI model, or you should not change the AI prompt. Only in the single prompt, you should keep on working on that one so that becomes your agent.
Sir, good evening, sir. This is Geeta, Chaitanya Kumar, sir.
Good evening, ma'am. Nice
Sir,
to meet
it
you.
was an excellent session. I've just listened from the starting when you have started till the end. It was an
Okay,
excellent session.
thank you, madam.
You made us to understand how exactly that AI agents works into.
Yes, thank you, madam.
Thank you, sir. Thank you.
Right.
So thank you so much, sir, for sharing your very wonderful presentation, sir.
Okay. Thank you, madam. Thank you.
Thank you. So myself, K. Menaga, Assistant Professor, Department of Cyber Security. So I'm the one of the coordinator of this FDP.
Okay, yes, ma'am.
So I would like to give the vote of thanks about the
Okay,
session. Okay, so good afternoon to all. It's my privilege to deliver the vote of thanks for today's session of the 6-day faculty development program. So on behalf of the Department of Computer Science and Engineering and Department of Cyber Security and the Center of Excellence in CINT, I extend our heartfelt gratitude to our respected insightful and inspiring session on from chatbots to AI agents, practical machine intelligence for education, industry, and daily life. Your valuable expertise, practical examples, and thought-provoking ideas have greatly enriched our knowledge and motivated all the participants to explore the future intelligence technologies. We sincerely thank the management of Dr. MGR Education and Research Institutes. Our special thanks to our respected Dean and HOD, Dr. S. Geeta Ma'am, and Dr. P. Dinesh Kumar Sir, HOD of Department of Cyber Security, give the support and encouragement throughout the program. Finally, we extend our sincere thanks to all the faculty members, participants, researchers for your active participation and enthusiastic involvement. Thank you all once again. Thank you, sir. Sir, would you please switch on the camera to capture you, sir?
Okay.
Thank you so much, sir.
Okay, ma'am.
Thank you, sir. Thank you so much.
Can I leave now, ma'am?
Yes, sir. Yes, sir. Yes, sir. Thank you so much, sir.
Okay, ma'am. Thank you.
Thank you. Thank you.